Hi, welcome to the class. Today we will continue with our discussion on chapter nuclei. The topics which we have discussed up till now is the mass defect and the binding energy. Today we will discuss radioactivity. Now what is radioactivity? So basically radioactivity is the spontaneous process. It is the spontaneous process where the nucleus disintegrate to give out the radioactive substances or radioactive materials. So radioactivity. So spontaneous process where the heavy nucleus, it basically breaks, and when it breaks it gives out the radioactive materials or substances, right? So that is radioactive. How many types of radioactivities do we have? We have basically 3 types of radioactivity. First is alpha decay, where alpha particle comes out. Now what is this alpha particle? Alpha particle is nothing but it is helium nucleus. This is helium nucleus. Helium nucleus. Now helium nucleus is a positively charged particle. Positively charged particle. And remember that this helium nucleus is a heavy particle. Why am I saying it is a heavy particle? Because it has 4 nucleons. It has 4 nucleons, right? And it is a positively charged particle. Now if I compare this, since this is positively charged particle, so I am comparing this alpha particle or helium nucleus with the proton. So if I compare it with the proton, what does it have? It has 2 times the charge of proton, because this is Z, atomic number, and atomic number is equals to number of protons. So it has 2 times the charge of proton, and it has 4 times the mass of proton. It has 4 times the mass of protons. 4 times the mass of protons it has, and 2 times the charge of protons it has. Why proton? Because it is also a positively charged particle. So that is there. So this is alpha particle, right? So whenever this alpha decay takes place, so let us take an example, general example, ZXA, and this does this alpha. So when it does alpha, alpha means helium nucleus. So the helium nucleus will come out. So plus 2He4. So helium nucleus comes out. So out of this Z, 2 particles have already moved out. So how much will be left now? Z minus 2. Why Z minus 2? Because out of Z, 2 have already moved out. Similarly, out of A, 4 have moved out, so it is A minus 4. Now remember one thing, this atomic number, which is the Z, is the identification of the particle, right? It is the identification of the particle. If this changes, the atom will change. Okay, so here atom nucleus was X, so here it will be Y, and some amount of energy will come. So that is there. So this is what we call alpha decay. Now examples you want me to give, so I'll give uranium 92, 238, alpha decay, it will be 2, it will be 234 plus 2, He4 plus some amount of energy, and this is thorium. So thorium comes out, right? So this is one example of alpha decay. So I hope you understood this. Now next is beta decay. Next is beta decay. Now what happens in beta decay? Beta decay. It emits beta particle. So what is beta particle? Beta particle is nothing but negatively charged electrons. So they are negatively charged electrons. So the symbol for negatively charged electron is -1, because their charge is negative. E is the charge of an, we use the symbol for electron, and 0. Why 0? Because their mass is negligible, right? So that is the this thing. So it has a charge of a electron, negative charge, and it doesn't have mass, or it has negligible mass. So that is there. So if I do it, it is again XZA. It gives beta particle. Then now what is Z? Z is the number of protons. Out of that proton, what goes out is -1 E0. So out of proton, initially the atom is electrically neutral, so it has equal number of protons and it has equal number of electrons. Now it has Z protons, so it must be having Z number of electrons as well. Now what has happened, one electron has moved out. So automatically, since one electron has moved out, so this number of proton will increase by 1, because initially the number of electrons and protons were same. But now since one electron has moved out, so it will increase. So here I will write Z plus 1. And obviously this mass hasn't changed, therefore I will write A, and I will write the mass number to be A because it will not change. Therefore it is Y to the power A plus this. And guys, mind you that this beta decay is of two types. One is beta minus decay and one is beta plus decay. In beta minus decay, which is in our syllabus, one particle comes and this particle is what we call anti-neutrino. Anti-neutrino. And if it is a beta positive particle, beta positive decay, this is beta negative decay. If it is beta positive decay, the particle which will come out to be is the neutrino rather than this anti-neutrino, right? So that is there. Now, if we write an example of this equation, it will be carbon beta minus decay. It will become 7 nitrogen 14 plus minus 1 is 0 and plus anti-neutrino particle. So that is there, right? So this is for beta decay. Now next comes is gamma decay. Now what is gamma decay? In gamma decay, gamma particle will come out. Gamma particle will come out. Gamma particles are nothing but they are the electromagnetic waves. If you remember, gamma particles are electromagnetic waves. And electromagnetic waves are what? Massless and chargeless. Massless and chargeless. So electromagnetic waves are massless and chargeless, right? So if they are massless and chargeless, they will definitely they are chargeless, so they will not change Z. So X will remain same. Massless, they will not change A plus gamma particle. Basically, the energy of the gamma particle is h nu. So it happens in the case of when a nuclei is in the excited state and it jumps down to some lower orbit. So when it jumps out, whatever energy it has taken up while going up, it gives back that energy in the form of photon. This is what happens. Okay, and it doesn't lose mass because whatever energy it is giving out, it is chargeless and massless. So that is there. So it works like that. Now, if we discuss these three on the basis of certain things like nature. So what was the nature of alpha particles? So they are positively charged helium nucleus. What is the nature of beta particles? They are negatively charged electrons. What is the nature of gamma particles? They are neutral short wave. In this case, you need to understand one thing, that gamma particles, since they are chargeless, massless, they are electromagnetic wave, and one important property associated with them is that they have the least wavelength and therefore has the highest frequency, and they have the highest penetrating power, right? So that is associated with them. Effect of electric and magnetic field. Obviously alpha and beta particle are charged, so they will be affected by electric and magnetic field, whereas beta particle is not charged, and gamma particle is not charged and therefore will not get affected by this electric and magnetic field, right? Ionizing power. Ionization means if there is a gas, okay, and gas particles are neutral. So if you throw a particle at them and when they collide, they basically takes out some electron out of it, charged particle basically, and then that gas particle, instead of neutral, now has become charged, because some particle collided with them, and because of that collision, what has happened is that some electrons has come out and it has become ionized, it has become charged. So who has the highest ionization power? So answer is the highest ionization power will be with alpha particle, because they are heavy particle. So they can during collision they can take out the electrons. Beta will have moderate and gamma will have the least, since they are massless. Penetrating power, which will have the highest penetrating power, as I told you, gamma has the highest penetrating power. Least will be by alpha particles, because alpha particle are the heavy particles, and then for beta particles it will be somewhere moderate between these two, right? So that is it. I hope you understood whatever is being taught. Thank you so much.